Welcome back to Introduction to Quantum Computing 2. So in Quantum Computing for All, the first course, we took a technology-centric approach and presented interesting physics phenomenon, what computation we can perform with it, and then what computation can we do faster than classical computing. And we just scraped the surface of this using the visual representation. So we sort of introduced the applications in the hardware and then went through the sequence of introducing some operations or the quantum mechanics phenomenon. And then we explored it through the visual representation. And then we introduced quantum notation and some mathematical calculation. And we ended up by introducing two algorithms that don't do anything useful, but provide intuition on how quantum computing and quantum calculations work and get speed up. In the second course, we're going to introduce the IBM QuizKit programming language at the very beginning. And so this time we're going to be introducing concepts again, introducing the related linear algebra, and then through both programming and linear algebra, exploring the implications on quantum computing. So this is much more of a programming and mathematically oriented class than it is just about gaining intuition. So we'll be building skills from individual operations to sort of the building blocks. We had a little bit of that before with the phase flip, the phase kickback circuit. So we'll be learning some building blocks, and then we will be building to more full algorithms, ones that are actually useful. And then we'll also be exploring some of these quantum computing concepts via coding, some of the things you can do and some of the limitations. And so we'll be using QuizKit, which is IBM software that they use for their quantum computer. And you'll need to make an account for that as soon as possible so that you can use the software. And we're going to keep building up those mathematics skills that are necessary for complex algorithms. So there'll be a lot bigger focus on math. So if we just distill it to the biggest differences between this course and the previous one, is that there's going to be very little visual representation. We've gotten to the end of what we can do with that visual representation because it has dramatic limitations in what it can convey in terms of the probabilities. And so we're going to be using very little of that. And instead, we're going to be using the mathematics and the linear algebra. And so hopefully that visual representation helped give you a sense of what that mathematic means, but we will be expressing it through mathematics this time. And there will be a lot more programming. And so for this course, there are some prerequisites. You do need to have some programming background so that you're comfortable with the very basics of programming. You don't have to have advanced programming, but you do need to have probably need to have some programming, and you need to be comfortable with mathematics. We will be teaching you the mathematics necessary, but we'll be using a lot of mathematical notation. And so if you're uncomfortable with mathematics, then you'll just need to take a little bit more time. But we will teach you, so there aren't explicit mathematics prerequisites, except that you should be comfortable learning the math that we present. So welcome to the course.